All right. So last day, so I guess Tuesday, we were talking about Lush Atelier's principle, which is what your lab this week is on. So some of you, I would say most of you have already done your lab. If not, you'll do it today, I guess. But it's a pretty cool lab, and it's based on shifting equilibrium. So we learned that there's so far, we learned that there's two ways to shift the equilibrium. We can change the concentration and we can change the temperature. And the idea is for either of those, if you add a reactant, it shifts away from that. It tries to reduce the change. So if we add a reactant, it shifts towards the products. If you add a product, it shifts back towards the reactants. That's Le Chatelier's principle. But there's another change that I didn't get to mention because we ran out of time. And it's most importantly, it only affects gases. And this is a change in pressure or volume. Remember, pressure and volume are basically the same thing. They're just opposite from each other. If you, for example, oh no, hold on. My pen is doing that thing that my pen loves to do. Hold on. Let me restart PowerPoint here. Just give me a second. Okay, let's try this again. Whoops. Sorry, talking to myself. Don't mind me. I opened up the wrong PowerPoint. Hold on. Technical difficulties. Okay, let's try this again. You'd think I'd have Zoom figured out after literally 1 year. But anyways, okay, let's try this. Okay, good. The pen is working. So sorry, back to this. Pressure only affects gases, and I just wanted to write that the relationship between pressure and volume are what we would call inverse. So if you increase the pressure, what you're actually doing is decreasing the volume. Or if you decrease the pressure, meaning you're kind of letting things get a bit looser, right? There's less pressure. That would mean increasing the volume. They are inversely related. So when you change pressure, it only affects gases in your equilibrium. Remember back from chemistry 1120 that solids and liquids are not compressible, which means the changes in pressure won't affect them, but it will affect gases. Now, this is a little different rule. The rule is when pressure increases, equilibrium shifts to the side with the least gas particles. And that is because we have less volume. Now, how do you know how many gas particles you have? The good news for you guys is this is extremely easy to do. There's no moles, there's no calculations, or well, no complicated calculations anyways. It's just adding and, well, that's it. So if I look at this equation, right, I'm splitting it in half. I have the left side being my reactants. I have the right side being my products. Here I have 2 plus 1. I have 3 moles of gas. Again, that's it. You don't need to calculate molar mass. I'm just calculating the actual particles or molecules of gas. So on the left, I have 3. On the right, I have 2. So the question, and I noticed somebody wrote in the chat, I'll check that out in 1 minute, but the question at the bottom says, what will happen if the pressure increases? Well, an increase in pressure means a decrease in volume. So there's less space. It will favor the side with the least amount of moles. So that means it will shift right. And that's it. And we're obviously going to practice this in a minute, so don't worry. But let me check the chat here, see what's going on. Yeah, there you go. Ooh, I got a lot of chats. I don't know why I missed all these. So yeah, good morning, Aaron and Harold and Aman. Yeah, I think it is a pretty easy question. And Abdul Halim and Abdullah, you're correct. It will go right. The easiest way for me to, like, again, I'm just kind of talking about myself and pretending like, you know, when I was a student, how did I figure this out? I always think about pressure and volume. And if you have a big space, like a big volume, you can have more moles, more particles. If you have high pressure or a small space, small volume, you have small moles, small particles. I mean, think about when you guys write a test. If you guys are writing a test for me, we can book a classroom or a theater. But in the final exam, we have 100 students, we need the gym. So more students, we need more space. Less students, less space. And the same thing happens in equilibrium. Less moles, less space, more moles, more space. I don't know if that makes sense, but that's how I always thought about it. So let's try another one. Well, yeah, there's my example, right? I don't know why there's a picture. These aren't my slides. I don't know why there's a toilet here, but you can see my example of like the classroom versus like the gymnasium, right? If you were going to, if we were going to have a test, if it was just you 30 students, small students, we could do it in the classroom. But if we were going to do it for every chemistry 1121 student, we'd need the gymnasium. All right, so this is a you know, wink, 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 winky, wink, wink. This is definitely a test question. Okay, you guys will definitely see something like this on your test at the end of the month. We'll have a test around the end of March, and on your final exam in around the middle of April. So how about this? I'm going to stop talking. I'm going to mute myself, and I'm going to give you guys 2 minutes to try this. I know some of you are using the PowerPoint or my notes. You might have the answers in front of you, but just try this and see if it's going to shift left or right. And I will be back in 2 minutes. And you can put your answers in the chat if you want. All right, so 2 minutes. Okay, sorry, back. I forgot to hit record. So question A, the equilibrium is cooled. I really appreciate you telling me that I'm not recording, because sometimes I forget, and that means the whole class gets ruined because it's not on YouTube. So yeah, thank you for that. Okay, so the equilibrium is cooled. This means we are losing a product, and the only way to fix that is to shift right. Okay, so this would shift to the right. I'm going to get rid of that arrow on top though, but there you go. The only way to fix the problem of losing a product is to make more. So it shifts to the right. All right, let's check out the next one. I'll pick a different color. Let's go green. The pressure is decreased. So pressure being decreased means more volume. So because we have more volume, we can handle more moles of gas. Ooh, so some people had the answer not correct in your in the chat there. So less volume means more, or sorry, increased volume means more mole of gas. So going up to this question, we have 4 moles of gas. And on the right side, we have 2 moles of gas. So if I decrease pressure, pressure's going down. That means more volume, which means more moles of gas. This would go left. Tricky question for sure. But, you know, there's worksheets on this. If you guys didn't get it right, you can practice. Okay, question C. Concentration of N2 decreases. Let's go with orange. So concentration of N2 is going down. The only way to fix that is to get more N2. What we're doing is we're losing a reactant, which means it's going to shift left. All right, cool. Let me check the chat here. Got another message. All right. Oh, yeah, the answer. Cool. Thank you, Aisha. And then finally, concentration of N2 increases. So let's go purple. Concentration of, concentration of NH3 increases. Sorry, that's what I meant to say. Okay, so we have, we're gaining a product, or we have extra product. Right, and we don't want extra product. That's, you know, it's too much. We're breaking the equilibrium. So again, that would go left. There you go. All right. So the answers to this are right, left, left, left. I think that's the answers. Yes. Ooh, I did it. The only one that you guys, I think when I was going through the chat, got confused with is B, the pressure. So remember, when you think about pressure, think about volume. Low pressure means high volume, more space. It's like writing an exam in the gymnasium, high volume. So we could take more moles of gas or more particles. Cool, cool, cool. All right, my chat's going crazy. Okay, well, yeah, so I have a couple private messages here, but people are asking if I can repeat B, which I just did, but I will, again, I'll mention it again. Pressure being decreased means more volume. More volume means we can have more moles of gas. Now, some of you guys, I'm sad about this, but I'm gonna clear my screen here. I don't want to though, it's so pretty. Well, I'll tell you what, I'm not gonna erase my screen, but I'll erase this part up here. Some of you might not know, what do I mean by more moles of gas? Okay, why is it going left? Why does the left have the most moles of gas? Well, what you do is you count the moles of your gas chemicals. Don't worry about solids or liquids. So I have 1 and 3. So 1 plus 3 is 4 moles of gas. That's the reactant side. And then on the product side, I just have 2 moles of gas. I don't have to add anything to it. Okay, so B, pressure is decreased, which means we have more volume, we have more space, so it shifts to the more moles of gas on the left. I hope that makes sense, because I don't know if I have many other ways to explain it. All right, so Aman and Aaron are chatting there. There's a good question about catalysts, which I'm getting to right now. Catalysts, they don't really shift the equilibrium. This is like a trick question if this was given to you on a test. Catalysts don't shift reactions left or right. All they do is make them reach equilibrium faster. Okay, so in simple words, just like we learned a couple weeks ago, or maybe 1 week ago, catalysts make reactions happen fast, but they're not going to shift the equilibrium. So there's the answer on the bottom there. Remember, catalysts increase the rate of reaction. So the question says, and this is definitely a wink, wink question, what will happen if a catalyst is added to this? Well, the forward and reverse rates increase, like the speed of the reaction increases, but it doesn't change Kc, so there's no shift. No change. That's typically a good trick question that we would put on a test. So like if you look at this example here, this is, I think, our last slide. Yes, it is. You can see sometimes wink, wink, wink on a test, we might say, what happens if you add a catalyst? And the answer is nothing. Or I guess you would say no change or no shift. Okay, it would go faster. It would reach equilibrium faster, but it's not going to shift left or right. Okay, so let me check the chat because there was a message in there. Okay, so sorry, I'm just reading the question. There's a lot to unpack with your comments and questions there. How do I answer this without confusing everybody? Hadil, you just raised your hand. Do you have a question?
Sorry, sir, by mistake.
Okay, no problem, not a problem. Okay, there's a lot to unpack with what you guys were saying in the chat there about H+. So you guys knew, when we were doing, in Unit 1, I'm just going to ignore what my pen is doing right now. Who cares? When we were doing the esterification reaction, we added H+ as a catalyst. Okay, but notice this is a reaction. It's not equilibrium. They're not the same thing. And again, all the catalyst did was help the reaction happen faster. You can't say it made it shift left or right because there is no left or right in a chemical reaction. Equilibrium has left or right. Reactions only go forwards. So you're kind of conflating or combining two things that shouldn't be combined. You're combining chapter 1, chemical reactions or organic reactions, with chapter 3, equilibrium. Not the same thing. So like I think you're thinking way too much into this. Catalysts do not shift equilibrium. They make reactions happen fast. That's it. Okay, so try to not think too much about this. Catalysts don't shift equilibrium. Boom, done. Halas. Okay, so I'll give you guys 1 minute to try these. And then we'll just it's almost 12 o'clock, so you guys will try these. I'll introduce chapter 4. Which is our second last chapter. So we're doing pretty good for time. And then that's it for today. So I'll give you guys 1 minute and I will be back. All right. Excuse me. So let's have a little look here. Well, first, let me see the chat. Oops, sorry about that. My phone went off. Ooh. Okay, so I'm getting some questions about D, and I actually didn't even look at D to explain this. D is way too hard for some of you, or most of us right now, but I will explain D. D is very tricky. I think Abdul Halim is on the right. Kind of right. Okay, so let's go through these, but guys, don't worry about D for now. D is, I'll put a little sad face there. I didn't even notice that that was there. It's a little tricky. So let's look at A, B, and C, and then I'll explain D. I don't think we're ready for D yet, but you will be ready soon. Okay. This is actually a tricky question now that I look at it. Oh, I should hit record again too. Sorry. Oh, I am recording. Never mind. This is a tricky question now that I look at it for two reasons. Well, one, part D is a very tricky question. And the other reason is the enthalpy is not in the equation. But I know from chapter 2 that this is endothermic, which actually means that my heat term is a reactant. Oops. Sorry, my brain didn't really do that, correct? So I know that the heat term is a reactant because it's endothermic. Okay, so let's look at this question. A, the pressure increases. Okay, so pressure increases. What that means is if we have an increase in pressure, we have less volume, which means it's going to favor the least moles of gas. Now, look at this question. There's only 1 mole of gas here on the product side. There's no moles of gas on the left, and there's 1 mole of gas on the right. So this means it will go left. If we increase the pressure, there's less volume, which means it will favor the side with the least amount of moles, which is the left side. Phew. Okay. Pretty tricky. All right, part B, a catalyst is added, no shift. All right, part C, the equilibrium is heated. Now remember, this is endothermic, which means when we add heat, we are adding a reactant. So we are adding reactant. And when you add a reactant, it goes right. All right, let me check the chat before I get into the big one. Question D. I think I'm going to upset some of you guys with question D, but soon we will learn a little bit more about question D. Okay, so question D, very confusing. NaOH is added. There's no NaOH in this equation at all. So what do we do? Right? What do we do if there's no NaOH? Oops. Well, we're going to cover this now in unit, or I'm writing that way too big. We're going to cover this now in unit 4. NaOH is a base. HC2O3 is carbonic acid. It's an acid. So do not worry about D for now. Okay, we will come back into D, or we will talk about D when we get into unit 4. But what's actually happening here is NaOH is a base. It reacts with the acid. Our acid is H2CO3. So what's really happening is we are removing a reactant, which means it shifts left. Oops, I don't know what happened to my word there, but that word says left. It kind of looks cool, doesn't it? Anyways, don't panic about D if you don't understand it, because we actually haven't talked about this yet. We're going to be doing this in Unit 4, which I'm going to introduce very quickly today. But the idea, again, for question D is NaOH is a base. Bases and acids react. So what happens is the NaOH, sodium hydroxide, removes some of the acid by reacting. And because we're removing a reactant, the equilibrium shifts left. Very tricky one for now. All right, let me check the chat. I got a lot of things going on here. Yes, actually, Abdul Halim, yes, you did something like this in the lab. You did add an acid to a system. I haven't done the lab in a few years, but you did. There is something like this in the lab. Aisha mentioned, so it forms salt. Yeah, it forms salt and water. It would form sodium carbonate and water. And then there's a private message I have that says our acid, or if both are acid or both are base. If we added another acid to this, you guys are asking some complicated questions. If you added another acid to this, I think technically it would shift right because you're adding more acid. If you added base to this, it shifts left because you're removing acid. And again, we're going to talk about this in chapter 4 because chapter 4 is literally called acids and bases. So to answer, you guys probably can't see this question, but the question was, what if you added more acid? If you add it more acid, then you're going to shift it right because you're adding extra reactant. All right, so now that you're thoroughly confused with my last question there, let's just take 5 minutes because it's already 12:06, and I just want to introduce the next chapter. This will save me time on Sunday. So here we go. Let's get into the next chapter. There's 2 chapters left, chapter 4 and 5. They're both around the same size as chapter 3, so they're not very big. Well, they're pretty big, but they're not as big as, say, chapters 1 and 2. Chapters 1 and 2 were huge compared to chapter 3, for example. So here we go, chapter or unit 4. Unit 4 is called, and I'm sad I don't have the name of the unit here, but it's called acids and bases, basically. Okay, so this is a really cool unit. For my medical science students, for my engineering students, acids and bases are so important in, well, for example, the body, the pH of your blood. You talk about acidosis or alkalosis for my medical science students. This is related to equilibrium of acids. For my engineering students, you guys will talk about using acids to, for example, clean things like cleaning metals, for dissolving clogs or, calcium buildups in like a well bore, which I talked about the other day. That would be a hole where you drill for oil. Acids and bases is something that as medical science students or engineering students, you can't really avoid. So this is a pretty cool chapter. It is related to chapter 3 as well. So we're going to talk more about equilibrium later in this chapter. Abdul Halim, this is related to your next lab. I think you guys have 3 labs left. You have 2 labs on acids and bases, and then you have a lab on electrochemistry. The next 2 labs, you actually won't really need any of these notes to do. One of your labs, you did the topic in chemistry 1120. It's a titration. Some of you in high school might have done a titration. So I think your next 2 labs will go pretty easily. But yes, your next 2 labs are about acids and bases, and your final lab is on electrochemistry. And in your final lab, you guys are going to be making your own battery. It's pretty cool. I like that last lab. Actually, I must admit, out of all the chemistry courses I teach, so like 1200, 1201, 1210, 3100, 2420, I mean, I can list them all. Chemistry 1121 has my favorite labs. I really like the lab that you did with the X, where the X disappears. You're making that stinky sulfur solution, and you look to see if the X disappears. I love that lab. I love the thermochemistry labs, and I really like the Lush Atelier's principal lab. So I'm kind of sad I'm not in your lab, but I'm also happy because then I don't have to get dressed up and wear a lab coat. So anyways, let's look at the definition of an acid. Just give me 2 minutes, guys. I just want to explain, let's say 3 slides and we're done. It'll be real quick. So there are many ways to define what an acid and base are. You guys talked about acids and bases in chemistry 1120 a little bit. Like you talked about naming or looked at formulas for acids. I don't think we spent much time on that, but really the big thing you need to know is in chemistry 1121, we are going to use the Bronsted-Lowry definition of acids and bases. So there's 3 definitions of acids I can think of are the Arrhenius acid definition. That was kind of one of the first early definitions. Then there's this Bronsted-Lowry definition. They're obviously named after scientists. And then the last definition, which is very useful in organic chemistry, would be Lewis. We are going to look at the Bronsted-Lowry definition, and wink, 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 you definitely want to know the definition of Bronsted-Lowry. Again, that's just the name of two people. You want to know this definition. So the Bronsted-Lowry definition of an acid, and you guys are going to hear me talk about this for the next week or two, is a chemical that donates, which means gives, a proton. Now, you'll notice I said the word proton. That's what H plus is. H plus is technically a proton. There's no electrons, it's just a proton. I don't care how you define this, it's up to you, but the definition is an acid donates hydrogen, ion, or a proton, whatever you want to say. So one thing you'll notice about acids is that all acids have an H in the formula. It doesn't need to be at the beginning, but it typically is. So Bronsted-Lowry acids are chemicals that donate a hydrogen. Bases are the exact opposite of this. Bases are chemicals that gain a hydrogen. They take a hydrogen. Bases take hydrogens from acids. That's the definition. So acids donate protons or hydrogen. Bases take those protons. Bases are typically negatively charged or neutral charged ions, or compounds. Bases are a little bit harder to identify, but acids are pretty easy. They start with H. Okay. I don't know if I want to do this right now. I think we've learned enough for today, actually. I mean, I guess I could do this, but it's 12:13. I think I'm going to stop here. This would probably take me 3 or 4 minutes to explain, and I already told you we'd be done in 2. So let's stop here. The end. We're finished. We'll get more into this on Sunday, and you know, you guys can go and enjoy your weekend. I'm sure you have classes today or something, but anyways. All right. Cool. So guys, that's it for me. I'm finished. Thanks, Hadil. Thanks, everybody. Thanks, Abdul Halim. Have a great weekend.
Thank you, sir. Have a great weekend.
Thank you. You too. Wear a mask. Wash your hands. I hope we all get vaccinated soon.
Sir,
Yes.
will you keep the tests for the next week?
There's no test next week.
No, I mean like the test we did. I want my paper to see where I went wrong.
Oh,
Is it there?
Yes, it's still there. The test will be outside my office for the next couple weeks.
All right, thank you.
Thanks. Keep safe, Harold. You too. Have a good time. Have a good weekend, I mean. Thanks, everybody. All right, see you later.